Okay, so tonight we'll be getting into 3D component families. And when you're choosing a new family template to start with, you have to ask yourself some basic questions about what you need your family to do. So what I'm going to get you folks to do is to go from the Revit desktop, close everything down so that you're looking at the Revit desktop like I am here. And we're going to look at the new family dialog box. So I'm clicking on new family here on the left. And it opens up this dialog box here which shows you all of the different family templates that ship with Revit. Now I'm just going to switch to the list view here so you guys can see the entire list of component family templates. So it looks like there's a lot of them. But it turns out there's actually not as many as you might think. Now you'll notice that a bunch of these say they are ceiling based. You'll notice some others that say wall based, roof based, floor based, and so on. And as it turns out, any of the ones that just say wall-based, roof-based, floor-based, they're actually really the same template. For example, let's look at generic model, wall-based. Now, you folks don't need to open it up. I'm going to do it here just to prove a point. So this is the generic model wall-based template. It is exactly like the template that you folks would use to build a new door or window from scratch. It doesn't have the opening in it, but what we're seeing here is a little piece of wall that one would use to build a door or window on. So, if I wanted to turn this into a door family, the little yellow folder icon up there in the top left corner, the family category, I could switch this from generic models to doors and hit OK. And now this is a door template. I'd have to put the opening into it for the door. But this is basically very similar to the door and window template. So I could go to that same dialog box again and switch it to a window. So you have three different templates that were in that original list that basically are all the same thing. So anytime you folks see wall-based, all of those templates are the same. So when you're building a new component family, so that's like a door, a window, some sort of object that you're going to load into your project to use. So last week we talked about in-place families, which are sort of an in-situ, one-off bit of geometry that you're adding to your project. So here, if we're building, say, a reception desk that's going to be used in a variety of different locations, then we would use the casework template for that. You can also see that there's casework wall-based. So the idea here, of course, is that that sound is the sound of my train of thought derailing. I have no idea what I was getting at here seconds ago. Middle age, man, it rocks. Frankly, it's been this bad since I was 30, so whatever. So these templates are all the same. So in a sense, there's less stress for you folks. However, the important question that you have to ask yourself is, does your family have to be hosted or not? Now, for a door family, obviously it's got to be hosted by a wall. Now let's talk about cabinets. If you make use of Revit's out-of-the-box cabinets for upper cabinets in the kitchen, those cabinets require a wall to be placed in before the cabinets will go. The upper cabinets require a wall to place those upper cabinets. We had a project that we were working on where the cabinets were going to be suspended from the ceiling. The uppers were going to be suspended from the ceiling. There wasn't going to be a wall. So now what? So we decided, well, we'll use the casework template that's not hosted, and we'll build our own upper cabinets. Now the advantage of having this wall-based cabinet is that, of course, if your walls move, your cabinets will move at the same time. If you elect to make all of your cabinets unhosted, when you move your wall, you'll need to make sure that you select your cabinets at the same time, or come back in a second pass, wrap those cabinets. So there's some of these decisions that you kind of make at the beginning, and you're committing yourself to some degree. You know, you can choose one of these templates and, as you saw, change its category. Probably not something you do very often. You might run into maybe something that might have a blurry line between whether it's millwork or furniture, right? Is millwork or furniture? Like, there can be some blurry lines there. Sometimes your cabinet maker might make something for you, and so you decide, okay, yeah, it is going to be millwork because my cabinet contractor is going to build it. But most of the times, the choice that you have to make is pretty clear. Now, with all of these, you know, if you choose the unhosted option for your template, so it's just a freestanding family, it's obviously not attached to anything. So if you had, say, for instance, when I was first getting started with Revit, you guys know those decorative wall braces that you attach on the outside of the building to make it look like an old world, you know, support for a roof overhang? Used to make those using the generic model family template, not hosted. So if the wall moved, that bracket was just kind of floating up in the sky. So we had to make sure that when we moved the wall that we came back and grabbed those brackets. The reason that we made them unhosted is because we tried making them generic model wall-based, and then there were times where we had a piece of trim that we had on the window, and the brace had to be placed on that trim that was around the window, just where that brace was going to land. So if we use the wall-based brace, it wouldn't stick because the window was in the way. The trim around the window was obscuring the wall. And you could turn the windows off and stick it in, but whatever. We said, forget it, we're gonna make it so it's freestanding. And then we had those situations where we had a side elevation where, like, yeah, we printed off these drawings and those braces are 6 inches off the wall, and don't we look smart now, right? So everybody's like, okay, we gotta recycle this paper and reprint before we show it to the client. So there is a special family in here. It is the face-based family, generic model face-based. And the nice thing about this is that you can stick this thing onto anything. If I were to go and take that decorative brace and use this face-based template, I could stick that template onto the trim of my window, I could stick it onto the wall, I could stick it onto the glass. And if that window moves back and forth, that brace is going to stay stuck to it because it's a face-based template. This is special, so you folks should be aware of it because there's lots of neat things that you can do with it. Let's talk about another situation. Let's say that now that you folks know how to do a slanted wall, a wall that leans. And as we'll see in a few minutes, if you have an angled wall and you put a window in that wall that's on an angle, a regular Revit window stays vertical no matter what. So if your wall is quite an aggressive angle on it, that window is going to look pretty stupid. The window does not follow the angle of the wall. So you're like, okay, what are we going to do? The generic model face-based template will follow. So what you can do is you can start with the generic model face-based template, change it to window category, and you're off to the races. So your generic model face-based template switch it to a window, and then you stick that thing on a sloped wall, and it follows the angle of the wall. We'll see that later. So all kinds of templates here, but really there's only about 6 or 8 different actual templates in this list. So it's kind of intimidating when you first look at it, but it's actually not a big deal. So the main thing you have to decide is, yeah.
So that means if you have a weird situation, you have to create the family from the beginning. Is there any way, is there any way to change the house for existing?
Sure. So the question is, what happens if you've committed and you've built a family and then you realize, oh shoot, I need to change the way that it's hosted. You can copy the geometry from your existing family into a blank template. Now there might be a few dimensions that don't come across, but you can copy that geometry over. So you might have to do some reassociation with the constraints, and we're going to be talking about constraints over the next couple of weeks. But that's, it is definitely possible. So in talking about hosted or not, we talked about the wall braces, we talked about millwork upper cabinets. Have a look in this room here. So when Revit was first coming out with light fixtures, these light fixtures required that a ceiling object was in place in the room for light fixtures to attach to. Well, we got no ceiling in this room. So we have these exposed ceilings where it's just a structure, and the stupid light fixtures that we got from Lithonia or Philips wouldn't stick to the ceiling. We're like, okay, now what? So what we would do is we would draw a little ceiling that was the size of the escutcheon plate above the light, and we'd stick it there. And then we'd make sure that when we inserted our light, we'd stuck it on that little piece of ceiling, and now the light fixture would obscure that piece of ceiling that was holding it up. So obviously, that's dumb. So what happens? Well, now manufacturers use the generic model, face-based family, for building light fixtures. And then you can stick it onto anything. You can stick it onto a ceiling, you can stick it onto the floor, you can stick it onto a roof, whatever. You can put that light fixture into place. So ceiling fixtures now, if they're built by a manufacturer who knows what's going on with Revit, that's the template they're going to use. Flip over to the next page. The ones with asterisks on them are ones that we don't really have. We're not going to be getting into how they're built in any great detail in this project, especially with some of the lighting ones, because building a light fixture is quite an involved process, often because the geometry of the light fixture itself is quite complex. So the different kinds of families that we have, looking at the bottom of page 2, we've got our unhosted families. So like the generic model family template. So if I open this up now, it's just open space. So I can build the geometry of whatever it is that I want, and it just sits in space. I insert it in my model, and there it is. It doesn't depend on a floor, wall, or ceiling for its existence in the model. So we've got our hosted families, which we understand, the face-based families, which I've told you about. I'll show you what that looks like, but we're going to work with it in a few minutes. So the generic model face-based, which is this one here, there's something a little interesting or different, I guess, about how you construct the geometry for your family. All of the wall-based templates presume that you're standing up and that you're looking at a vertical wall surface, a vertical wall, and you build the geometry of your family, a door, a window, whatever, while standing up. That's the direction. You're looking horizontally. With the generic model face-based family, this thing is sort of lying on the floor, so you're looking down as you're building it. So let's say that you are building a light fixture for someone, and you're going to build it, and you want to build it using this generic model face-based, so you switch it straight away, to a lighting fixture. There we go. So now it's considered a lighting fixture, just like that. It's not a generic model, it's a lighting fixture. But you're building this thing while looking down. So what you're looking at is the face onto which this family will be placed when you're done. So if you're building a fixture, you're building it like on the floor. So then that fixture is going to be taken up and put on the ceiling. So it'd be like taking these light fixtures down, spinning them around so that they're illuminating upwards. So you kind of build it upside down if you're building for a ceiling. Just so you know. If you're building a window, you're looking at what would be the outside face of the window. So when you're looking downwards, it's like you're looking at the outside face of the wall, lying on the floor, and that's how you build your family. The next template of interest here, just so you're aware of what's going to be coming at you in the next couple of weeks, is the line-based family. So there's a template for 3D families, line-based, and there's another one over there in the first column. It's called detail item line-based. These are a special stretchable family. Colloquially amongst Revit users, these line-based families are called two-pick. And what they mean is you pick 2 points on your screen and your family stretches to fill that space. So a classic example of what this line-based family will be used for, you folks know that often a cabinet maker will build a series of cabinets and they've got some leftover space at the end between the cabinets and a corner. So they'll put in a blank filler piece, right? It doesn't operate, it's just finished to match the adjacent doors of the cabinets. How long is that filler piece going to be? Don't know. So what you can do is you can build a little bit of cabinet, however long you stretch it, however apart those 2 clicks are when you place the family. So you need 2 clicks to place the family if you use the line base. You need your starting point and your ending point. So you go click, click on your screen, and the family fills that space. So we're going to have templates that work with that. So we're going to be seeing that soon. So that's another special template. So you decide on the hosting, whether it's hosted or not. You decide whether it needs to be 2-pick or not, and most times it isn't. And away you go. Now, depending on the category that you choose for your family, so let's flip over to page 3. The geometry in certain kinds of families appears cut in section if the plan cut plane cuts through it, or if you cut a section through it. So, for instance, generic model. If you build, now I'll just demonstrate here. If you build an extrusion here, and let's say that this extrusion, don't follow along, keep your eyes on the screen. So here I've got a 6-foot tall extrusion. And I have chosen to make this family generic model category. Now, I'm just going to create a new project here. Again, don't try and keep up, just keep your eyes on the screen here. So here's my family, 6-foot tall extrusion. So it basically just looks like a refrigerator, just an extruded square. So if I load this now into a project, there it is there, and let's zoom in on this thing. This thing is being cut by the plan cut plane. Remember that your view range in any given plan is at 4 feet. This extrusion is 2 feet tall, so the plan cut plane catches it at the 4-foot mark and it appears cut. Now, if I go back to my family here and I make it only 3 feet tall and load it back into my project, it now appears not cut, i.e. shown in elevation. So generic model behaves that way. Well, what happens now if I go back to making this 6 feet tall but I changed the category. So right now, if I go up to the family category button up on the top left, it's generic model. Now let's switch it to specialty equipment. This is the category that's used for things like file cabinets. So if you download a file cabinet from the internet to use in Revit, it will be specialty equipment category. So it's still 6 feet tall. Now, if I load it back into the project, I'm redefining it, so now it's the same family name, but it's a different category. So now it doesn't appear cut. Even though it's 6 feet tall, it doesn't appear cut. And that's because specialty equipment always appears as if you're showing it in elevation. Now, if you guys remember, Revit has two ways for how geometry is shown. This isn't the right category. Object styles. So in object styles here, you got the two categories, projection and cut. So geometry is being shown in projection. Those lines are in the background and they're being projected towards you. If you just see the outline of an object that's not being cut, it's being shown in projection. But if you're actually cutting through it in section or in plan, it gets a heavier line weight. But specialty equipment is never shown cut, even if you are cutting through it. Some categories allow you to decide if you want to show the geometry cut or not. So if you look at the table there in the middle of page 3, so it's got the family category, and the option is whether that particular category gives you the option of whether this geometry is shown cut or not. And this is by default. So if you want to show your lower cabinets as being cut by the plan, cut plane, you can choose that yes option inside the family. So again here folks, just keep your eyes on the screen. I'm going to change this thing again. Now actually here, this is good. I'm still specialty equipment. What I'm going to do is I'm going to click on this solid. So this is just an extrusion. We're going to talk about all the different modeling tools that you get in families here pretty quick. In your families, for each solid that you make, whether it's the window frame or the glass or the door, what have you, each one of those solids has controls so that we can decide how or when this geometry appears. Now, when we were talking about structure, do you guys remember how we were looking at an open web steel joist, and at the coarse level of detail, you didn't see the webs of the joist, right? And at the medium level of detail, you saw the webbed lines, but that's it. And then when you went to the fine level of detail, you saw the whole shooting match, right? You saw everything. So what that means is for those detailed webs of our open web steel joist, that geometry has these two boxes unchecked. Coarse and medium are unchecked for those webs in an open web steel joist. So this means that unless the level of detail for the view switches to fine, this particular solid that we've modeled here will not appear. But what I want to talk about right now is there's this when cut and plan option. You folks see it there? It's grayed out. And it's unchecked. What does that mean? It's unchecked. It means A, you can't change it, and B, it's never going to be cut. So that's specialty equipment. I'm going to go back and change the category back to generic models. So after I've done that, I go and click on the solid again and go back to its settings here for how it shows up in our drawings when we load it into a project. And here it's still grayed out, but now the box is checked. So you still don't have any control about whether it is shown cut or not, but it will be shown cut. You don't have any choice about it with generic models. So if we look at casework. So again, changing the category, going up to casework and choosing that. So I just click it, hit OK, that changes the category of this family. So now when I select this solid and go to visibility settings, look at that. So it gives you that control about whether you want to show that geometry shown cut. I have to be honest with you folks, I might have used this checkbox in the family maybe once or twice. I guess it's been specific use cases where people have asked this from Revit, and they've put that into the software. Now let's look at the other options here for your geometry when you add it to a family. So when we build a window, for instance, now I'm not going to draw the wall. I'm just going to draw the door, and we're going to talk this through together. Now, one of the things that's absolutely irritating about the out-of-the-box doors is that they don't show a frame. They show the door leaf, and they show the trim on the outside, but no door frame. So, okay. I model my doors when I'm building my own doors, and I do model the frame. So I'm going to show it to you here. I'm just kind of doing a quick little isometric up. So there's my door frame. And I modeled it as an extrusion. And I model it in elevation. So that's the view that I'm looking at when I make my door frame. So I'm not showing the little bit of wall that comes around the frame in the door template, but it's there. Now, I also model the door leaf. And the frame is still there, and here's my door leaf. Okay, now when we build a 3D door for ourselves, and let's say that I have a light in it, and maybe I've got a little piece of trim underneath it that's got some bead boards, so it's kind of a nice country style door here, with some glazing in it. That nicely modeled door that I've taken all the time to build up, do we want to see it in plan? Do we want to see our door modeled closed and show it closed in plan? No, we don't. So, our frame, yes, we want to see that in plan. We want to see it in elevation. We want to see it in section. We always want to see the frame. But the door, we only want to see the 3D door leaf in our elevation views and in 3D. If the door swings in a certain direction, we're going to do those as 2D lines, and we'll talk about what they're called in a family here in a few moments. So again, 3D door leaf, not shown in plan. So if we click on a piece of geometry, we can say that this geometry doesn't appear in plan. So this means if I was looking from another story up above and my view range was such that I could look down and see this door, that geometry would not appear in any plan. If the plan cut plane happens to cut through the door, I can choose whether this geometry appears or not. So these two checkboxes do different things. This one will allow this geometry to show up in plan if the plan cut plane cuts through it. But it would not appear if shown from a story above and the view range was deep enough to see it, and you were in wireframe and you could see it. This combination means that if you were in wireframe and you could see through to this geometry, it would appear, but it won't appear when the plan cut plane passes through it. So for a door leaf, this would be the proper configuration for that 3D geometry that's part of your door, whether it's the glass or the leaf. So this geometry will always appear in 3D, and it will always appear in my elevation views. So that's the proper settings there. So on the bottom of page 3, those are what those settings are for, and the different combinations, or what those different checkboxes are for. So bottom of page 3, 1, 2, 3, and 4 has the two combinations of those checkboxes and their function when you're building a family. Let's go over to page 4. So regardless of the kind of family that you're working on, the user interface that's presented to you when you're making an in-place family or a component family, this particular arrangement of tabs on the ribbon, this is called the family editor. So the first button here to talk about is the one that I've been showing you here, family, category, and parameters, where you can change the category of the family that this particular object is going to belong to. Okay, the next thing to talk about here is the Create tab. The Create tab is where all of your 3D modeling tools are provided. The next tab we're going to talk about here is the Annotate tab. These are your 2D tools. So for putting in dimensions, also for the door swing, that's considered a symbolic line. So a symbolic line is to a family what a detail line is to your project. So you folks know that if you create a detail line in a particular view of your project, you only see that detail line in that view. So in Revit, if you create a symbolic line in a plan view in your family, it only appears in plan views in your project. So symbolic lines, when added to a particular kind of view, will only be visible in that kind of view when loaded into the project. So if I go to the Annotate tab here and I draw some symbolic lines in my plan, those lines will appear in my plans in Revit, but not in my elevations. Okay, so the important thing here that as we start getting into modeling geometry inside our families is the process that we use for modeling. Now in the context of a project, if you're building a project, of course you define your levels first and then you put in your grids, and that helps you sort of organize the geometry of your project. In families, the most important organizational element, and this is on your final exam and it's on your next exam, the most important organizational element in your family is the reference plane. The reference planes are the bones of your families. If those bones move, the body moves. If those reference planes move, your geometry moves with those reference planes. They are the means by which we stretch or make our families flexible. So you folks have all made new doors and windows of different sizes, and all of those geometries and doors and windows change their shape and size because of reference planes inside the families. Once these reference planes have been put in place, we use on the Create tab, so right beside the reference plane command is the Set Work Plane command. Now if you made extruded roofs, in the intro course we talked to you about how reference planes are used in your projects and how you can use the Set Work Plane command inside a project to begin or to set the start point of an extruded roof. Same thing here, that set work plane. We used that a little bit last week when we were working with that in-place desk. Okay, so let's take a break for 10 minutes here and then we'll come back and start on page 5.